Hi everyone, welcome back. All right, you have made a tremendous amount of progress. We're going to start by doing a very brief review to make sure that you can assess your own understanding of what we've covered so far so that you have a good grasp on the basics. And then we're going to launch into the second half of the 6 classes of nutrients. So remembering back to the very beginning, the key point, everything is chemicals, right? All nutrients are chemicals. All matter in our world is comprised of chemicals. So what is food? It's just a big mixture of chemicals. So we shouldn't be scared of the word chemicals. We shouldn't be scared of words that we see in ingredients list that we're not familiar with because they may not mean anything that's a point of concern. They may be the chemical name for some sort of a valuable substance for our health, or they may be an inert or neutral substance that is not in any way harmful, but that is essential to enable us to prepare foods in bulk and distribute them for consumption. So fear-mongering, once again, is not what we're here about. Food is our friend, and it's all about understanding how much is the appropriate amount. How much is enough? How much is too much? Everything in moderation. So first you learn that there are 6 classes of nutrients, and water is that which we need the most of, hence it makes up the bottom of this pyramid. You then learn that about 45 to 65% of our daily calories should come in the form of carbohydrates because these are an energy yielding substance, and that's why it's the next largest part. And then we need a greater proportion of proteins from our food every day than we do of fat, but we do need both. And then we need minerals and vitamins, and we need them in much smaller quantities. So you learned about the macronutrients, the carbohydrates, the lipids, and the proteins. And you know that carbohydrates and proteins contain 4 calories per gram and that fats contain 9 calories per gram. And then we went through each of these carbohydrate, protein, and fat sections and looked to some degree at a very basic level at what these nutrients are all about. So let's do a quick summary review of each one. You learned that carbohydrate is the chemical name for a compound made of 3 elements, carbon, hydrogen, and oxygen. Hence, we abbreviate carbohydrate, CHO. You learn that it has 4 calories per gram. So carbohydrate is an energy-yielding nutrient. It is meant to be the body's preferred and primary source of cellular fuel. You learn that once it is absorbed into the bloodstream, that it becomes blood glucose. Some people say blood sugar, but the formal or clinical term is blood glucose. And again, it travels through our circulatory system via our bloodstream to all of our trillions of cells that then take up that glucose and use it to generate energy to drive everything that's going on inside that cell, such as the production of proteins that you learned in turn direct your body to do all that it does. You did learn that aside from that which is absorbed into the blood for delivery to our cells, some small amounts of carbohydrate are taken up by our liver and by our skeletal muscles and stored there in a storage form called glycogen. And again, that's so that we have a little emergency reserve. So if we are sleeping or we have gone too long without having a chance to eat, our liver can release a little burst. It can turn that stored glycogen back into blood glucose. And the same thing can happen when our muscles are called upon. In other words, we begin to exert ourselves, whether it's for physical exercise that's intentional or we're fleeing someone or something that's chasing us. Our body has that fuel reserve. It's limited in both cases, but it can carry us a short while. Again, your body does that as a survival mechanism. It doesn't want to exhaust its blood supply of its primary and preferred fuel source, blood glucose. So in these instances where it is not getting enough of what it needs because you're sleeping or you've gone too long without eating, or your body is being called on above and beyond its normal requirements, you have a little extra something to get you by. You learn that carbohydrate, again, is the chemical structure that gives form or structure to all plants. And therefore, when we look at the stems and the leaves, whether we're talking about nuts, or we're talking about the seeds of plants, or we're talking about grains, or we're talking about fruits, or vegetables, or legumes, we are looking at things with structure. They're not puddles of liquid. And they have that structure thanks to linked chains of sugar molecules. You learn some are singular monosaccharides, some are two joined together disaccharides, and some are long strands of sugar molecules called polysaccharides. Collectively, you learned that they're either starches or fibers that are linked together forming polysaccharide units, and that those are what give structure, and that contained within those plant foods are the single and the two, the mono and the di, and those are just called simple sugars. We just call them naturally occurring sugars if they occur naturally within nature's creations, such as breast milk, which can come from any animal, right? A cow, a goat, or otherwise, as well as in plants. So all plants and dairy, you learned, contain carbohydrate, and you learn that eggs and meat are the dead flesh of animals and or the unfertilized products, and therefore they have no circulatory system, and therefore there's no circulating blood glucose. Therefore, they do not contain carbohydrate. All of what I just said should be stuff that you already know, that you learned. If any of it is elusive to you or unfamiliar, the best thing you could do is go back and watch the carbohydrate lecture. Carbohydrate is the most challenging nutrient for most people to understand. So you did learn sugars, starches, fibers, and the unique thing you learned about those fibers is that we do not as human beings possess the enzyme to break them down, to digest them. So we say fibers are indigestible. Now, we didn't get into all the different types of fiber structures, such as soluble and insoluble, but fiber does exist in these different forms. People often ask me, well, which foods have soluble fiber and which have insoluble fiber? Because I heard some types of fiber are better for certain reasons. Yes, soluble fiber does certain things, insoluble fiber does other things. But any food that contains fiber contains both kinds of fiber. Some foods might have more soluble fiber, some foods might have more insoluble fiber. But it really doesn't matter. Keep it simple. Foods with fiber contain all kinds of fiber, and you want all kinds of fiber. So the more fiber-rich foods we consume, which are plants, the more likely we are to get what we need. So you learn too how to read a nutrition facts panel, and you learn that the very first and primary tool is to look at the percent value, because when you look to the far right, it is telling you the percent of the dietary reference intake that is contained within one serving of the item. So you can look at the top and you can see what is a serving. Remember, that doesn't mean what you should serve yourself. It just means the unit of measure to which this information applies. So whatever this is, if you were to consume 2/3 of a cup of it, you would get these percentages of the daily reference intakes. So the daily reference intake for any one of these nutrients might be an adequate intake, like fiber. We don't know exactly how much is ideal, but we know what is adequate. So there is a recommendation for fiber, and if you look on this line, you can see that this particular serving contains 16% of that daily reference intake, of that adequate intake. And since 15 means significant, you can say, oh, this contains a significant amount of fiber. In other cases, you know that some things you don't want a lot of. So when you look at the saturated fat and you realize that it is 5% of the daily reference intake, and you know that saturated fat is harmful in excess, therefore there's a tolerable upper limit for it, then this is 5% of the tolerable upper limit. In other words, 5% of the maximum amount we should consume in a day. So 5 is low. So there is a low percent of the DRI in one serving, which means that gives you more room for more fat throughout the day. So you were taught first that the total carbohydrate line is that which most people can ignore. It is the total of all forms of carbohydrate, sugars, starches, and fibers. And most people will never need to assess the total carbohydrates. That line, as I previously indicated, is for people with diabetes, but only those individuals with diabetes who have been taught how to properly use it. If someone has never been trained by a medical professional how to use that information, then it's going to be useless to them. And we'll look briefly at how to do that at a later time. So we can disregard the total carbohydrates line, as you learned. You also learned that we don't have to look at that sugars line, right? Because there is no percent value there, so we ignore the sugars line, because on the traditional label, or the old version that is still in use in most cases, that is the total of all sugars, both naturally occurring within the plants or dairy, and those which have been added by a person, whether it's in a restaurant or at their home, or by a manufacturer in the manufacturing process. So any sugar that has been added to something is an added sugar, and we know that it is nothing but calories. And therefore, we want to focus on foods that contain a lot of naturally occurring sugars because, hey, they're part of that big package, that mixture of chemicals, right? So what we care about are those added sugars, but if there is no added sugar line, we had no way to know other than to look at the ingredients list and look for words that mean added sugar, and ideally there are none, because again, we don't want a lot of added sugar. We want as little as possible so that when we do consume it, we can afford to consume what we do consume. Personally, I'd rather everything I consume have no added sugar in general so that I can use all of what I am able to consume safely for dessert. So why do I want it everywhere else, right? So you learn that the type of carbohydrate on the label that we want to focus on is fiber. We want to look to get as much as possible. But you also learned that unfortunately there are many marketing gimmicks designed to sell us products that are not particularly beneficial to our health, but, they want you to think so. So they add a lot of chicory root or inulin, as you learned, and then technically, because those are forms of added fiber, the fiber content does go up. But the caveat is that it is not in the same form as the intact fiber that would have existed in the plants, and therefore, while it won't harm us, it is not going to afford us equal health benefits. And where are you going to find a lot of added fibers? In highly processed manufactured products. Great-great-grandma and everyone that came before her who's eaten food throughout all of mankind's history never had chicory root and inulin added to their food because they only ate what nature created. They didn't eat highly processed manufactured foods. So the closer we get back to what people have been consuming since the beginning of the time, the fewer things we have to think about and the fewer worries we will have. So you also learn that the new label has been implemented by some manufacturers, but that it's not an obligation to commit to it for some time still. So occasionally we will be fortunate enough to encounter one of the new labels, and that's fabulous because it actually has a line that shows us the added sugar. There is a tolerable upper limit for added sugar. So there's no dietary reference intake for total sugars, the combined or lump sum total of added and naturally occurring, but there is a daily reference intake, a TUL, a tolerable upper limit, for added sugars because we want to limit them. So when you see here that one serving of whatever this is contains 20% of the tolerable upper limit, a high amount per serving, that is a terrible choice, unless that's that occasional dessert you've decided to hold out for. Then we looked at fat. You learned that fat serves a variety of functions. It helps make up our cell membranes. It coats our nerves with a sheath to protect them. It allows us to absorb fat-soluble vitamins and to store or sequester some of them inside of our body to use them up gradually. It pads our organs so they're not slamming into each other. And it insulates us to help with temperature regulation. Fat has over twice the calories of carbohydrate and or protein at 9 calories per gram. And when we consume more fat than we need, the body cannot do anything but store it as fat. So it becomes body fat. The more calories that we consume, the more likely we are to consume excess calories. And our body doesn't care where excess calories come from. Don't forget that. Once we got all the carbohydrate we needed for our blood, a little got tucked into our liver and our muscles, and any extra was turned into fat. Once we got all the fat we needed for all of these functions, any extra is turned into fat. And the same is true for protein. Once we get what we need, any extra is turned into fat. Extra calories become excess calories, and the only thing the body could do with excess calories is turn them into its sole fuel storage source, body fat. So in all foods, we will find fat except most fruits. Now, many people forget that botanically speaking, meaning in plant terms, certain things are labeled as vegetables in a culinary setting, like an avocado, but they are actually a fruit. A tomato often gets referred to as a vegetable, but it's a fruit. Some fruits, like avocados, are going to contain fat, but most of the things that we think of as fruits don't contain fat or contain such a tiny amount it wouldn't even be worth acknowledging. You learn that fats are linked carbon molecules, long chains of carbon molecules stuck to hydrogens. You learn that if there is a hydrogen attached to every carbon, we say it is fully hydrogenated. It is fully saturated. It is a saturated fat. It's a chain of fatty acids, so it's a saturated fatty acid chain. You learn that if any of those carbons are missing a hydrogen, then there is a point of unsaturation. It's an unsaturated fatty acid chain. So you learn that we just call these fats either saturated fats or unsaturated fats. You then learned that amongst the unsaturated fats, some are monounsaturated fatty acids, MUFAs, and some are polyunsaturated fatty acids. So those with more points of unsaturation, MUFAs and PUFAs, the unsaturated fats, are those which A, have more beneficial impact on our health, and B, do less harm. So we want to consume mostly unsaturated fats, MUFAs and PUFAs, and a minimal amount of saturated fat. We need some saturated fat, as you learned, but there is a tolerable upper limit because scientific research indicates that excess saturated fat is associated with a number of health concerns. So what's that amount that's excessive? We set a tolerable upper limit, and that's why we're able to use the NFP and look for 5% or less. You also learned that the cholesterol intake of some people is a concern. Now, cholesterol is a type of fat. It is produced in the liver of all animals, right? And you're an animal. So humans produce cholesterol in their liver, and some humans produce too much. It's a genetic flaw. And in those people, there's going to be a result. High blood cholesterol. So those people will have to take medication that tries to make their liver produce less, but then they'll also have to be careful how much dietary cholesterol they consume, because if their body's already making too much and they're getting too much from their diet, that's a double whammy, right? So you learned that we don't really know how much cholesterol is too much. We're just not sure. So it's best to err on the side of the caution and go for low amounts as often as possible. And then you learn that trans fat is a particular structure of a fatty acid that does exist in all animal foods, but in minuscule amounts. And what we have seen is that when manufacturers create trans fat in a laboratory, by transforming unsaturated fats into saturated fats, that particular creation, that specific form of trans fat, has done a great deal of harm to human health, and so it has been banned from the food supply. There are very few exceptions. So there shouldn't be a lot of trans fat in our world, and the less animal foods we eat, the less we'll get of it. And so we all know more plants, fewer animals, in a multitude of ways translates into better health. There's room for both, but the dose makes the poison. So you learned, as you look at the label, there's no percent on the trans fat line. It can't have a percent of 0, right? We want none. The DRI doesn't exist because we want none. So we should see 0 grams there. If we see a number there indicating anything more than 0, that's not something good. That's a bad choice. We learned that we can disregard the total fat, right? Because the total fat line is the total of all the fats, the saturated, the trans, the muffas, and the puffas. Why do we not see the muffas and the puffas on this label? Because as you learn, most of the nutrients listed on the nutrition facts panel are those which are problematic. We're trying to help people steer clear of making poor choices. So if somebody sees that there's something that contains too much saturated fat, too much sodium, too much cholesterol, too much added sugar, they can choose not to choose it. And by default, by not choosing something high in harmful things, then they will inadvertently be choosing an alternative that is going to be high in good things. So the less saturated fat and trans fat, the more of whatever fat is in here is good fat, muffas and puffas, unsaturated fats. So when we choose things based on low amounts of harmful substances, what we do is we trade off. We say, it's got low amounts of the stuff that hurts me. That means that most of whatever's in here is the stuff that helps me, right? Because remember, good nutrition is not just about avoiding harm. It's about seeking out things that do good. So when we avoid excess saturated fat and we avoid trans fat, we by default end up getting lots of unsaturated fat, which has beneficial impacts on our health. When we avoid lots of added sugars, we by default end up choosing foods abundant in naturally occurring sugars, which are part of packages that contain a wealth of valuable nutrients. When we choose foods with a lot of fiber, assuming it's not in some added form like chicory root or inulin, then we are choosing plant foods that nature has created that are not just full of fiber, but because they're plant foods, they're full of other beneficial nutrients as well. So by looking at one perspective, we trade it for the value of the alternate perspective. So you learn 5% or less is low. We want low saturated fat and we want low cholesterol. And then we looked at protein, and we looked at the fact that, yes, we all think of structure. We think of muscles. That gives our body rigidity or structure. Some people know that proteins exist in bones as well. Anything with structure, your hair, your nails, all of these things are common knowledge in terms of structure. But what about all the other things protein does that no one ever thinks about? Like wound healing when you cut yourself or injure yourself. Transporting substances through your body. Remember, hemoglobin, we've all heard of, is a transport protein that transports oxygen through your body. Without oxygen, you would die. We learned that protein acts as enzymes. This catalyzes or makes happen chemical reactions in the body that sustain us, biochemistry, the chemistry of life. You learned that hormones are proteins, so insulin is one that most people have heard of. Antibodies, our immune system is constantly fighting our battles. It needs proteins to do that, so it makes protein antibodies. And proteins do all kinds of jobs in our body to keep everything in balance, to make sure our blood's not too acidic or too alkaline, to keep everything just right. Of course, it has calories because it's a macronutrient. So it has 4 calories per gram. So of the amount of calories you need each day from protein, you need those 4 calories from each of those grams. But you also need the other component of the protein that is not calories, that is the functional part that does all of these things. If you consume more protein than you need, as I said before, don't forget, that just means you're taking in extra calories. You have no storage form, so it gets converted to fat. You learned that proteins are linked chains of amino acids adjoined by bonds called peptide bonds, and that when we take in food, digestion breaks those peptide bonds and singles out each one of those amino acids. They enter the bloodstream, they travel to the cell takes them up and rebuilds them back into functioning proteins, like enzymes or hormones or antibodies. And you learn that it is not until it folds up that you have a completed protein, and that becomes relevant again in this week's section. You also learn that protein is technically in all foods, yep, even in fruit. Although most of the time we say, yeah, you can get protein from everywhere but fruit, because there's so little in fruit that it's not really worth counting it. But technically it's there. Do you know how you know it's there? Because when you speak of an allergy, of someone being allergic to something, what that is their body's immune system responding to a particular type of protein. And people can be allergic to fruits. People are allergic to citrus fruits sometimes, for example. That tells you there's proteins in there. But in terms of getting protein for our dietary needs, fruit's a really poor source. But that leaves what? That leaves animal foods, right? Eggs, dairy, and meat, very rich sources. Very close equivalent, nuts, seeds, and beans, legumes. These things are rich sources of protein in the plant food world. Whole grains, not so great, but definitely some. And then produce, vegetables, and fruits, much less. So again, we know that when we look at the nutrition facts panel, we always want to look for the percent, right? So you learned there is no percent on the protein line, so we can ignore that. And you learned that that's because there is no dietary reference intake, no recommendation for daily protein intake, because we all have such unique needs. We're all individuals in different stages of life with different levels of activity, with different health needs. All sorts of things factor into how much protein we need, and it changes throughout the course of our life. So the protein on the label here would only be useful to someone who has been instructed to look there and told specifically what to look for. So, for example, I am a registered dietitian nutritionist. If I had a patient who had kidney failure and that person was not on dialysis, I would want them to restrict protein. So I might tell them, I want you to look for things with less than X number of grams of protein. I would decide on what number to tell them based on the person. And so they could look at something, and if they saw a number greater than what I told them, they could decide not to choose it. That's really what it's there for, guys, because you can't go through the day adding up all your protein intake. If something doesn't have a label, and hopefully most of what we eat doesn't have a label, right? Because we're eating nature's creations. If it doesn't have a label, then you don't know how much protein's in it. You can only estimate. And who wants to keep a running tally all day long anyway? The idea is that protein, as you learn, is very easy to get from nature's creations. Again, it's in all animal foods, it's abundant in nuts and seeds and legumes, there's a decent amount in grains, and technically, it's even in produce. And don't forget the last thing you learned about plant chemicals. You learned that phyto means plant, and plant chemicals are evidenced by their color. They are part of what gives things pigment. So the bright colors of the rainbow indicate phytochemicals, which you learned act as a phyto shield, protecting your cells from the damage caused by oxidation occurring inside of you. You learn that they act as antioxidants, opposing oxidation. You learned from Dr. Lee's video on anti-angiogenesis that they can stop the growth of harmful blood cells that surround tumors. In other words, they can keep the vessels from proliferating or reproducing so that the tumor can't receive nourishment and grow. In other words, they can stop cancer from being created, and they can help treat cancer. Plants are powerful, folks. The more plants we consume, the better. So now we move on to the micronutrients, vitamins and minerals, and that last class of nutrients out of the 6, water. Remember, foods are packages of chemicals. They are combined mixtures. They are carbohydrate, they are protein, they are fat, they are vitamins, they are minerals, they are water. So where you get one, you get others as well, and oftentimes all of them simultaneously. So let's start with water. Now, unlike many other things, it doesn't contain carbon, but again, it's a good old chemical structure, hydrogen and oxygen, which is why we call it H2O, and you are largely made of water. In fact, for most of your life, you are about 60% water. Now, you can look at different places, you'll see 65, 70%, whatever, it's all an estimate, but you are more than half water. As we age, we lose more body water and we have a harder time retaining it. So once you're into your 80s, you're going to be more like 40-45% water. And that's why hydration is so important for the elderly. As we age, our thirst mechanism, that thing that triggers thirst in us, is suppressed. It diminishes. And so as we age, we don't feel as thirsty. Well, the problem is, when you feel thirsty, that's your body's way of telling you you're already dehydrated. So we always want to proactively hydrate. We want to make ourselves always be drinking water so that we can get it. Now, what is water? Well, water is really anything that's fluid. So if you're drinking milk or juice or tea or coffee, that's still water, right? You don't have to drink pure water. Some people say, well, don't some things make you urinate more? Don't they have a diuretic effect like coffee and tea? That's a little old school. We used to say that. Now we go, you know what? The value of the water trumps any of the diuretic effect of the caffeine, so it still counts. Do you want to know how much water you need? Well, we don't have an answer for that. The old adage is 8 8-ounce glasses a day, but there's really no science to support that. So here's a really simple way to know. Pee. Look at your pee. If it's really light yellow to clear, you're well hydrated. The darker it is, the more water you need. That's the simplest way. Can you drink too much water? Sure, but it's highly unlikely. That's only in situations where people are doing crazy things that include some sort of a routine of taking in massive quantities of water. It's incredibly rare. Most of us, that is the least of our concerns. So we want enough water because it's the medium for everything that's going on inside our body. In other words, it's facilitating everything that's happening. Everything chemically takes place in water or requires water to happen. So we can't transport things through our body in our watery blood if there's not enough water to make our blood watery. Chemical reactions in our cells can't take place if there isn't water there to be the medium for those chemical reactions. Water creates fluids of all kinds throughout our body, whether it's in our joints or around our organs, and it keeps everything kind of suspended so it's not slamming all together. And finally, we can perspire, we can exhale. We can do things that allow us to adjust our body temperature by expending water or taking in more water to regulate temperature. So you learned that most nutrients are absorbed in the small intestine. That was one of the first lessons, that everything comes in your mouth, goes down your esophagus, hits your stomach. It leaves your stomach and it goes into your small intestine, and most nutrients, carbohydrate, fat, protein, and vitamins are absorbed there. So that leaves two things, right? Water and minerals that got to be absorbed somewhere, which means they're absorbed in the next part, the colon, which is also called the large intestine. Why do you care? Because we're going to connect back what you've learned so far to why you care in terms of health conditions. And if you understand something about your anatomy and physiology, your pieces and parts and how they work, and how it is that nutrients have an impact on health, then you'll be able to understand why, when things are out of whack, diet matters. So remember, you are nothing but trillions of cells. You're just a massive collection of cells. And those cells themselves make up your blood vessels, but your blood vessels are running throughout your whole body. So your blood vessels are made of cells, and they are also running amongst all of your trillions of cells. So you're nothing but vessels and cells. And so if we zero in on that, we see a blood vessel, the red thing. The plasma would be your blood running through the blood vessel. We see all these little round things, these cells. And inside the cell, inside, is the intracellular fluid. Outside the cells is the extra. Exit is to leave, to go outside. So extracellular is outside of a cell. Anything outside of the cells is extracellular fluid. So extracellular fluid can be interstitial fluid, that which directly surrounds the cells, or it can be intravascular fluid, that which is inside the vessel. So what I want you to know are the terms intracellular fluid and extracellular fluid. Inside the cell, outside the cell. If it's outside, it's either around it or it's being moved into the blood vessel. So look at it in a different light now. Now you see what I'm talking about. You can visualize it a little bit better. You can see that interstitial and intravascular are the two types of extracellular. But we're going to speak in terms of intracellular and extracellular. So again, about 60% of you is water until you get up until your 80s, right? So a lot of it is inside your cells. It's intracellular fluid. And some of it is outside your cells, whether it's surrounding them, bathing them, or it's in those blood vessels. Your water. Although water makes up the largest percentage of our total body volume, it's not just pure water, right? It's got stuff dissolved in it, like the glucose, the blood sugar, the proteins, the substances that are traveling everywhere in your body are in that fluid. So all of your fluids are not just pure water, they have things dissolved in them. So for those of you who are less chemistry savvy, look at the picture here. What is a solution? A solution is a liquid with stuff dissolved in it. Well, the liquid is called the solvent, and the stuff that dissolves in it are called the solutes. So a solute is a substance that is dissolved in a solvent. You do this in cooking all the time. You add something, say you're cooking something and you whisk sugar into eggs. So if you're whisking the sugar is what? The solute. Into the eggs, that's the solvent, right? And oftentimes we do that in the early stages of some sort of a baking. You're constantly pouring salt into vinegar to make dressings and such. So there's many examples. So the same things that go on in the kitchen go on in your body. It's all chemistry. Give you a moment to digest this. Remember, can always ask me for the slides if you feel like they'd make a good study tool. All you got to do is reach out. So water is called the universal solvent. In other words, everything can dissolve in water pretty much. So we look at it as body water being what everything dissolves in. Everything you inhale dissolves in the fluid in your body. Water in your body is soaking up everything. Everything you ingest, whether it's an illegal drug or a prescription drug or an over-the-counter drug, whether it's food, whatever you take into your body through your skin, inhalation, or oral ingestion enters your body and dissolves into your body fluids, which means everything you're exposed to circulates throughout the entirety of your being, and every inch of you is exposed to it. Now, hopefully you've heard of the word homeostasis somewhere in your K through 12 education. Homeostasis is all about keeping everything in balance in the body. You are just a big piece of complex machinery, and the goal is to constantly be righting everything. If the seesaw tips one way, tip it back the other. Keep everything in balance. So your body says, oh, the temperature went up, bring it down. Oh, the blood sugar went up, bring it down. Oh, the blood pressure went up, bring it down. It's constantly seesawing, trying to keep everything in balance. So one of the essential homeostatic functions, fancy way of saying ways the body keeps everything in balance, is that a fluid balance, right? And your body says, okay, there's constantly stuff coming in and I need to move it around because if there's too much water over here, there won't be enough dissolved stuff over there. Everything's dissolved in water, so we want to keep everything balanced everywhere. We don't want too much of anything collecting over here and not enough over there. We want equal amounts inside cells, intracellularly, and outside cells, extracellularly. So everything's got to be moved around, and we can thank water for that. But what is going to make that water move around? Well, you're going to learn in a short while that electrolytes are a big factor there. And what many people don't realize is that when I say electrolytes, I'm talking about a class of nutrients called minerals. So hold that thought. So think of it like this. Fluid serves as a transportation vehicle in your body. Water is transporting all substances. It's saying, hey, I got everything on board. Let's travel through the entire circulatory system and drop off stuff at every cell that needs it. Oh, while I'm making that stop, let me pick up all the waste products from whatever already happened in those cells, and then we can take everything back in liquid form, dissolved in the water. All that water goes over, circulates through the vessels to the kidneys, and says, let me flush out all these waste products. So the water goes through the kidneys, and it takes all the waste products with it, and it exits your body in the form of what? Urine, right? So metabolic waste products is a fancy way of saying all the garbage that needs to be taken out after your cells do what they do. Metabolism. Metabolic waste products are the garbage that comes from metabolism. Chemical reactions, right? Biochemistry. Everything inside of you is chemistry. Bio is life, the chemistry of life. All of the thousands of chemical reactions taking place inside of you require that water. So we have to remember that there are constantly things going on 24/7 that need water, and that's why we don't want to run low on it. So earlier in reviewing proteins, I reminded you, you eat and food contains proteins. You digest the food, which means you break it down. But you don't just break down the food itself, right? You break down all of the nutrients. So those proteins, as you know, are linked chains of amino acids. You break them apart. They become singular amino acids. They get absorbed into the bloodstream. They get delivered to the cell. The cell takes them up. It says, thank you very much. Let me check the instructions I have, and I will build a protein the body needs, an antibody, a hormone, and so on. And water is necessary for that new structure to fold up because the shape of the protein determines its function. It has to fold in a very specific way to do what it needs to do, and without enough water, it can't do that. So if someone's dehydrated, it is literally impairing the chemistry inside their body and resulting in problems. Water, again, lubricating everything. If you've ever had a swollen knee, maybe you know that that's called synovial fluid, that lubricating fluid in your joints. And if your joint cartilage, the padding there, wears down too much and the bone starts rubbing bone on bone, all of that friction triggers your body to secrete more of that fluid to try to act as a cushion, and it over-secretes it, and then your knee swells all up. So when we look at our spine, we have fluid in between all of our vertebrae. And the same thing happens there. If you have a compressed disc and friction, then that synovial fluid is trying to build up. And sometimes we have to extract some of it if there's too much built up for different reasons. And as you look, you can see where all the fluid is distributed through all the different tissues of your body. These are just some examples, but look at how every part of you is largely made of fluid. It comprises all of your organs. Remember, your eyes are an organ, your skin's an organ. Everything you see here, even your muscles, are organs. Everything's an organ. So your organs are largely made of water, and thanks to that water, they cushion your organs as well. And again, as we said, body temperature. This is really easy to understand, right? Your blood vessels dilate. That means they get bigger. They widen. And that allows more heat to escape your body. And then the sweat glands secrete more fluid, and that cools the body down. So it takes it from too high to lower. It regulates body temperature. The same thing if it's cold outside. The blood vessels constrict. They get very narrow so that heat is conserved, so you won't sweat, so you won't lose fluid. Pretty cool when you stop and look at it. So, moving from water into the micronutrients. Remember, macro means big. You look through a microscope, you're looking at something small, right? So macronutrients are larger, micronutrients are smaller. We still need a lot of them, but part of the reason they're smaller, if you remember, is because they don't contain any calories, right? So micronutrients include all vitamins and minerals, and they are required in lesser amounts than the macronutrients, but we still need plenty of them in order for our body to do what it needs to do. They're not optional. So the difference is that you take in those macronutrients and they are directly used to generate fuel for your cell. They contain calories, right? They're metabolized to generate fuel. Micronutrients are necessary factors in allowing that to happen. You go to work and you have a coworker, somebody who helps you get the job done. So when we have enzymatic reactions inside our body, enzymes, making things happen, making chemical reactions occur, we need some helpers. We need some coenzymes. So I know you've probably all seen or heard some reference to B vitamins giving people energy, and that is not accurate. B vitamins cannot give you energy. I will say it again because right now somebody's freaking out. Taking B vitamins does not give you energy. B vitamins are coenzymes. In other words, they are a partner in the metabolism of energy-yielding nutrients. They help your body convert carbohydrate, protein, and fat into usable cellular energy. So yes, if you didn't have enough B vitamins, then your body might not use carbohydrate, protein, or fat as efficiently as it could. But first of all, you have to have enough fuel. Carbohydrate, ideally, fat, and a little bit of protein. and you need it in the right proportions for your body to use it correctly. And secondly, it is incredibly difficult not to get enough B vitamins. So, like with all vitamins, the chances of not getting enough in this country are slim, guys, because our problem here is not that we can't get enough food. We get too much, right? Undernutrition is the least of the concerns for most of us. Overnutrition is the problem. Even cruddy food, whatever you might want to term junk food or less than healthy food, still has vitamins because all food is a mixture of chemicals and they're in there somewhere to some degree. So it is not hard to get enough of any vitamin, B or otherwise, if you're eating well. If you have a disease that makes your body need 10 times more than usual, then maybe because you're sick, you can't even eat enough to eat normally, to get enough that you normally need, much less all the extra. So a disease could cause an increased need. If you have severe injuries like burns or multiple broken bones, your body may need more vitamins and minerals, in which case you're going to try to eat more, but if you can't, it might be hard to get enough. If you have a disease that prevents your body from properly absorbing vitamins and minerals, they just pass on through and go out with your feces because you have an intestinal disease maybe, then it's not that you're not getting enough, it's that you're not absorbing them. So getting enough is rarely the problem. If there's a problem, it's due to illness or injury, and that is what must be addressed first. You have to know why there's a problem before you can come up with a solution, right? We don't just say, oh, you need to get more of this. We want to fix the problem, not just try to slap a Band-Aid on it. So I know that we all live in a world where we are inundated with messages indicating it's hard to get enough nutrition, and that's marketing, guys. There's tons of money to be made by telling you that. The supplement industry for nutrient supplements, pills, powders, and other potions is a multi-million-dollar industry, and I will talk about it separately at another point. But suffice it to say that food first is the goal, and when you eat food, what are you getting? Packages, mixtures of a wealth of valuable nutrients. You're not just getting a certain vitamin or just protein. You're getting the whole kit and caboodle. And so when you eat food, you get to do two things. You get to get pleasure, because who doesn't love to eat? And you get to meet your body's needs. And the chances of not getting what you need become slim when you are meeting your body's needs by giving it healthy foods. Only if you have a medical problem or injury might a supplement be appropriate, and in those cases, that's to be determined by a qualified medical professional like a registered dietitian, nutritionist, or a medical doctor. So let's just look right here at the difference between the micronutrients, vitamins, and minerals, keeping in mind that the word organic is not referring to how food is grown. That's a different use of the term, organic farming. Organic simply means in chemistry carbon-based. So you saw, for example, that lipids or fats are made of linked carbon molecules. So that's what we mean by carbon. So when they say complicated organic substances, they mean they're carbon-based. So minerals are not carbon-based. That's all it means from a chemistry standpoint. We are able to get vitamins from all plants and animals. You can get vitamins from all food sources. Now I want you to think like this. Minerals are of the earth. Sorry about that. So when you picture the ground, the dirt, that's the earth. And the earth is made up of minerals. Plants grow in soil. So that's how the plants get the minerals. Then animals eat the plants. We're an animal, maybe we eat the plant, and that's how we get the minerals. Maybe a cow ate the plant, and it got the minerals, and then we ate the cow, and that's how we got the minerals. So when they say found in soil and rock, they're saying that minerals are of the earth, and that all plants and animals capture them. So vitamins and minerals, let's just simplify it, are everywhere. Now when you cook foods, Vitamins can be destroyed very easily, which is why the cooking techniques matter. Minerals are a bit more sturdy, right? And ultimately, we need a whole lot of vitamins, and we need them all to some degree. Minerals, there are some we need more of and some we don't need nearly as much of. In fact, some of the minerals we get, we may be getting enough just from the dirt stuck on our plants, right? The little trace amounts of soil residue. So we're not going to get into the complexities of all that in this course. I'm just giving you a very basic overview at this point. As you look here, you see A, K, E, D, C, and B. The C's and the B's. So you see there is vitamin C, one. You see there are a multitude of B vitamins. So the B's and the C are the water-soluble vitamins. They dissolve in water. Soluble means dissolves in something. They dissolve in water. That means they dissolve into your body's fluids, like blood, and can go to all your cells. It means they dissolve into that blood so that when that blood travels through your kidney, they go out through the kidney in the form of urine. So when we consume a lot of water-soluble vitamins, whether it's from food or supplements, the body says, thank you, I got what I need, flush the rest. That's why taking a lot of supplements of B's and C vitamins mostly just generates expensive pee. Supplements can be really pricey, and most of them are going to go out in your urine. Your body doesn't need but so much, and when you exceed what it needs, it can't store them in any way. It just flushes them out. So most of us can get plenty from food. Again, under the guidance of a medical professional who has evaluated a person and told them you have a unique need that necessitates the use of a supplement, then it would be appropriate. But if you've never been evaluated and instructed in that way, then you have no way or reason by which to determine that you need a supplement, and chances are you get plenty from food. And if you think, as many people say to me, but I don't like healthy food, I don't want to eat healthy food, I'd rather take supplements, they're not the same. What nature created and what was created in the laboratory are simply not the same. And so when we look at all these vitamins, please keep in mind that food is what we are focused on. Vitamin A, vitamin D, vitamin E, vitamin K, these are fat-soluble vitamins, so they dissolve in fat. So foods with fat are going to have fat-soluble vitamins. And that means that they're going to dissolve into the fat in our body too, which means we need even less of the fat-soluble vitamins because we store them in our body and can release them as needed in small amounts. So bio is life. Bioavailability, available to life. Bio is your body, the life of you. So bioavailability refers to the proportion of a nutrient that is absorbed and used in the body. And what we know is that the nutrients contained within foods created by nature, plants and animals, are those most bioavailable. The body says, hey, I know you, I recognize you, come on over here, let's do our thing. Supplements, a large portion of them are going to pass through unabsorbed, and they are not going to be utilized as efficiently. Ultimately, we're each going to absorb a different amount because we're all unique individuals. And again, when we are focused on getting a mixture of nutrients in our diet from a variety of foods, we're more apt to hit all the bases. Because again, supplements are not the same thing, and supplements are concentrated doses. One pill is going to have oftentimes 10 to 100 to 200 times more than what you would have gotten from your diet. Too much of a good thing is not a good thing, right? There's such thing as harm. Anything that has the power to do good has power, and power can be equally detrimental as it can be beneficial. So let's look at vitamins. Vitamins are organic. They're carbon-based. And they're either water-soluble, they dissolve in water, or fat-soluble, they dissolve in fat. They do lots of important things. They help make blood cells. They help make bones. They help you see. They help your nervous system function. They fortify your immune system to fight your battles. And if someone has a true vitamin deficiency, literally the body is not getting what it needs, again, usually because its needs are so elevated due to illness or injury that they can't possibly eat enough to get enough of it, or because they're excreting too much of it due to illness or injury, then they're going to have a true deficiency. Most people aren't going to have a deficiency just because they eat cruddy. Even those of us who eat cruddy probably aren't going to have a lot of true deficiencies. We might have not quite as much as we'd like to have, but to be truly deficient is another story. When somebody is truly deficient, not an adequate amount in the body, it manifests in vitamin deficiency diseases. Very specific signs and symptoms. So the fascinating thing is that the body can actually synthesize some vitamins, make some. Let me give you an example. Vitamin K. Your colon, your large intestine, if you recall, is made up of a lot of bacteria. There's good bacteria and bad bacteria. And so that bacteria that's good is good because it does things like make vitamin K. So all of us as adults were exposed to all kinds of things in our world. Once you're a child growing up and into adulthood, you're exposed to all kinds of things. You're touching things, you're inhaling things, you're ingesting things, and everything has bacteria. You are a big pile of bacteria, basically. There are more pieces of bacteria on your body than there are cells. I've said that before. So that bacteria can produce vitamin K. That way you don't have to get that much from food. But a brand spanking new baby, boink, pops into this world, hadn't been exposed to anything. That colon, that large intestine is sterile, totally clean. There's no bacteria there yet, so it can't make vitamin K. And that's why we give newborn infants an injection of vitamin K at birth. We want it to inhabit their intestines and then produce more. A day or two in this world, they'll be exposed to a lot of bacteria. Within a few weeks, they'll have plenty of bacteria in their gut and start making their own vitamin K. Cool stuff, right? So here's a visual to help you differentiate. But if you look at the fat soluble and you look down, you'll notice that the acronym, and when you have letters that kind of spell what sounds like a word, we call it an acronym, ADEC. Like you walk out on a deck and stand there, right? ADEC. If you can remember ADEC, you can remember ADEC are the fat-soluble vitamins. That means A, D, E, and K are fat-soluble, B and C are water-soluble. Easy way to do it. I don't expect you to know B1, B2, the names. There are only a few that we're going to focus on. So here's another way to look at it. I'm going to let you have a moment. I'm going to stop talking and let you read. Okay, so looking right here, what you're looking at are foods rich in water-soluble vitamins. What do you notice they all have in common? Plant foods, right? Fruits and vegetables. So folate is the first one I want to draw your attention to. And I'm going to tell you a couple of things here. Folate is in leafy green vegetables and beans. So anybody ever ask me as a registered dietitian nutritionist, what food would you say everybody should eat? I say two words, beans and greens. Everyone who's ever met me knows I'm all about beans and greens. Remember legumes, all kinds of beans, black beans, pinto beans, black-eyed peas, kidney beans, the list goes on. Beans and greens. Swiss chard, kale, spinach, asparagus, broccoli, cabbage, turnip greens, collard greens. Beans and greens mean folate. Why do you want folate? A lot of reasons, but let me tell you two really good ones. Folate reduces internal inflammation. And in the simplest terms, inflammation inside the body encourages the development of all kinds of diseases. You got high blood pressure, you got inflammation. beans and greens will help reduce inflammation that increases blood pressure. You got heart disease or vessel disease of any kind, you got inflammation. Anything that is a disease causes inflammation. You got diabetes, you got inflammation. You got arthritis, you got inflammation. You got an autoimmune disorder, you've got inflammation. You got cancer, you got inflammation. And the list goes on. Anything that harms you causes inflammation. If you bang your hand right now against the chair or the table really hard, it's going to get inflamed, right? Everything happening inside you that's harmful is banging the heck out of your insides. It's causing inflammation. Any external injuries are causing inflammation. And something called homocysteine in our body rises in response to inflammation. Folate helps counter homocysteine, pushes it down. So when you hear people talk about anti-inflammatory foods, they mean things that oppose inflammation. And your best friends are beans and greens because they are so rich in folate. Yes, other foods contain it well, but those are your best sources. There are also great sources of a whole other array of vitamins and minerals. They contain water. They have a little bit of protein. They are great sources of fiber. See how you get the whole kit and caboodle. The other reason you care about folate is because not every woman that's ever gotten pregnant was planning it, right? So, any woman who is of childbearing age, which means menstruating, whatever age that is, any woman who's menstruating is of childbearing age. And any woman of childbearing age who engages in sex could potentially conceive a child. And at the point of conception, a new human being begins to form. The very first stage of development, if you don't know it, is called a zygote. And at that point, folate must be present, or certain things will not develop correctly. There's no way to make up for it later. Sometimes it's physical birth defects that will result if enough folate wasn't there. Sometimes it manifests later in life. It becomes obvious that someone's intellect, their mental abilities are impaired. But there are some very, very obvious physical birth defects that can result from folate deficiency. So think about women of childbearing age, typical women, let's say 20-ish year olds in their 20s. How many of them do you think in today's world have the healthiest diets and eat loads of greens and beans? So there's one reason for you to understand that eating healthy at all ages matter. It's not something you do when you get older. Then it's too late. It's something you do from the day you were born. And you do it from the day you're born so that you form a habit that follows you through your whole life. Right? You don't want to have to make changes later. You want to do it from the get-go so it's easier. This is why as parents we want to raise kids on healthy foods so they don't have to try and change bad habits later. And this is why as parents we would want to emulate healthy eating habits to our children, not just so we're healthy and can be there for them, but so that we are good role models to teach them what's important to do. And that way when people make new people, they have what they need in their body to make them. Another one we want to focus on is cobalamin. See how if you saw that word, you'd go, eek, chemical. Chemicals are not always bad. It's just B12. So let me tell you a little bit about B12. After about age 50, physiologically, the aging process starts to take a toll on us. Pieces and parts are wearing out. One of those problems is that the stomach does not continue to produce as much of something called intrinsic factor. Maybe you never heard of this. But intrinsic factor, IF, is a substance produced by the lining of your stomach. It is what allows you to absorb vitamin B12 in your stomach. So if you don't make enough IF, you don't absorb enough B12. And after age 50, you make less IF, so you absorb less B12. So it is more likely that after the age of 50, someone could potentially become deficient in B12. So oftentimes, health professionals will tell people over the age of 50 to take a B12 vitamin supplement just in case. Won't hurt them, might help them. When people have certain diseases, a prime example being diabetes, for reasons too complicated to go into here, they have a harder time absorbing B12. So we may often tell people with diabetes to take a B12 supplement. They may not need it, but if they do, it will help them. What's the big deal if they don't get enough vitamin B12? Well, one thing is, not enough vitamin B12 results in damage to nerves. And so at a later point, when we talk about diabetes, I'll refer back to this and I'll explain a little bit more. Who is most at risk for vitamin B12 deficiency if they're not over age 50 or don't have diabetes? One category of people. Vegans. What's a vegan? Remember, that's somebody who consumes no animal foods of any kind, right? So only animal foods, eggs, dairy, meat, contain vitamin B12. So if someone consumes eggs or dairy or meat, which includes seafood, they'll get some. They don't have to consume all three. Any animal food means they get B12, and you don't need much, so it's pretty easy to get, and your body actually stores this particular B vitamin for a long time. All the others are water soluble except this one. I'm going to keep it simple and leave it at that. So people who are vegan generally need to take a B12 supplement. The last one, again, ascorbic acid. Oh, there's a chemical in my food. People have said that to me so many times over the years when they're looking at a label. No, there's vitamin C in your food. Everything's a chemical. It's just the chemical name for what you call vitamin C. It has a lot of value. It's an antioxidant. Remember opposing oxidation? Remember, oxidation damages cells. Damaged cells divide and become more damaged cells. Those damaged cells cluster together and form tumors, which you associate with cancer. Antioxidants. Remember, many phytochemicals act as a phytoshield, while many vitamins act as antioxidants. So everything is about protecting your cells. So the more vitamins and minerals we get, the more cellular protection we get to ward off all kinds of problems, including cancer. So, beans and greens, beans and greens. You must know that moving forward. Of course, I'm going to have that on the remaining tests. And when you design a healthy meal for your project, I would expect to see beans and greens there. So, briefly, back to cooking methods. When you boil vegetables, what happens? The water turns the color. The water here would be green. And what do you do with that water? You usually drain it off unless you're making soup, okay? That would be the one exception, which means that a lot of the phytochemicals, since that's the color in our vegetables, has leached out into the water along with a lot of the water-soluble vitamins, and down the drain they go. So boiling vegetables, unless it's soup and you're going to consume the liquid, is not a great idea. That's also the problem with canned vegetables, because what do you do when you open the can? You drain them. So yeah, tomato products, oftentimes we use tomato sauce, so it's a non-issue. Sometimes you use the liquid in the tomatoes, so it's a non-issue. Beans, you're going to rinse those. That's not quite as much of a deal. But pretty much any other canned vegetable, it's not just because so many of them are high in sodium that we don't love canned vegetables in the world of nutrition. It's also because you drain them and get rid of a lot of the nutrients. Now, if you got low sodium canned vegetables and you didn't have to drain them, fabulous. And of course, canned vegetables are better than no vegetables. But whether they're frozen or fresh, steaming them, which means they never make contact with water, is going to enhance the preservation of nutrients. So when you do a course project and you're preparing any vegetables, I would expect that they would be roasted or part of a soup or a stew where you consume the liquid, or steamed. And that takes us to good old A deck. Anything with fat is going to have a fat-soluble vitamin, and technically there's fat in everything, even in teeny tiny amounts. So even fruits and vegetables have some fat. The difference is that some foods, when we consume them, or supplements for that matter, when we say, oh, I'm getting vitamin A from my carrots, or oh, I'm going to take a vitamin D supplement, they aren't in their active form. they're in what we call a precursor form. And in general vocabulary, the word pre means before, right? So a precursor is something that comes before something. For example, in a different context, you might say there was a little shock wave that ran through the ground. It was a precursor to the big earthquake, something that comes before something else. So in nutrition, when we talk about vitamins in an inactive form, we say that's their precursor form. They have yet to be activated. So there are vitamins that can only be activated within the body once they have been ingested in their precursor form. So you eat a carrot. People go, carrots make you have good eyesight. That is because carrots contain vitamin A in a precursor form. And once you ingest it, it goes through several different chemical conversions inside the body, and it becomes active vitamin A that does in fact help promote good vision. You can get active vitamin A in all animal foods. When you eat plant foods, it's the precursor form, but as long as all of your body functions are normal and you don't have any major diseases, you should be able to convert it just fine. Let's use vitamin D because that's a much more relevant example. Most vitamin D production in humans is thanks to sunlight exposure. Again, you got to forget the world you live in now because this is not the world you were designed for. You were designed for survival, right? And throughout most of our history, up until 100-ish years ago, life was so different. We weren't inside in air conditioning, sitting in front of a computer listening to this lecture. We were out doing stuff, farming, hanging our clothes on a line, walking where we needed to go, hoeing out in the fields, all these different things. We were getting sunlight whether we liked it or not. And our body was designed for that because man has always been outdoors. And so when the sunlight makes contact with our skin, those UV rays trigger some cholesterol, some fat underneath our skin to make this substance. And it's got a really fancy name, 7-dehydrocholesterol. And then that heads on over to the liver, and the liver goes, ooh, let me convert you into something else. And the liver converts it into another fancy name, 25-dehydroxyvitamin D3. Then that goes, let me head on over to the kidneys, and the kidneys go, let me convert you again into another fancy form, 125-hydroxyvitamin D3, which you call active vitamin D. That's the vitamin D that does stuff, like helps you absorb calcium so you have strong bones. So think about this. If sunlight is the way we were designed to make it, and we don't get enough sunlight, there's a pretty good chance we're going to be vitamin D deficient. There's not a lot of vitamin D in foods. There are some foods that have more than others, but that's still not a lot. You still probably wouldn't eat enough of those foods to get enough vitamin D to meet your needs. So some degree of sunlight exposure is necessary. You live in a world where we do everything to extremes. Everything's always black or white, all or nothing, good or bad. And hopefully I've given you the impression at this point that we don't want to think of food as entirely good or bad. It's all about dose makes the poison. Well, the same thing applies to sunlight. The dose makes the poison. I'm not suggesting you go lay out in the sun for 3 hours. 15 minutes of sun exposure on your arms and legs, and if possible, your stomach or chest, a couple of times a week is often enough, especially if you're fair-skinned, right? If you're darker complected, you're going to need a little more because the whole point of your dark pigment is to reduce the absorption of UV rays, because people of darker pigmented skin are from parts of the world, ancestrally speaking, that are closer to the equator, and so that's a protective mechanism in their skin so that they don't overproduce vitamin D. So fascinating, right? So most of us need some sun exposure, even darker skinned people, and they need more. So ultimately, sunlight is the way to make it. It's hard to get through foods, and you don't know if you are vitamin D deficient unless you have your blood tested. We don't have blood tests for all vitamins these days. You can't just go get a checkup for everything. But when you go for a regular annual checkup at your doctor every year, and I say that because I'm trying to impress upon you how important that is, And they check your blood glucose level to see if you're pre-diabetic or have diabetes. And they check your liver function. And they check your kidney function. And all these things so you don't one day get real sick and go, oh, nothing was wrong with me, when it was. Well, while they're checking all that, you can say, are you going to check my vitamin D? Because I would like for you to. Because if your vitamin D level is below a certain number, then you either need to get out and get a little sun, or if there's a reason that's not an option for you, you're going to have to take a vitamin D supplement. And not just any old vitamin D supplement in any old amount. You need the guidance of a medical professional. We tell you which one and we tell you how much based on what your number and needs are. So I encourage you to get that done, because we have linked inadequate vitamin D to a whole host of health problems, including diabetes and cancer and Parkinson's disease and Alzheimer's disease, and the list goes on. Nutrition is so important, guys. It's not a fad. It's not a trend. It's not a thing that some people do and it's their thing. It's a human thing. It's a matter of quality of life, not just life and death. So let's go back to this coenzyme thing. Remember, vitamins are coenzymes. And I'm going to give you a moment to look at this picture. I'll be quiet. So this is why we're saying vitamins help your body to engage in biochemical reactions. They don't do things themselves. They are helpers. They are co-workers, co-enzymes working with enzymes. And so we don't need a lot. We just need enough. Food can do it. As you look here, you can kind of get a feel. I don't expect you to memorize all this or anything, but vitamin A, again, we associate it largely with vision. You can see foods there that people eat. That's just an example of things to show you how easy it is to get vitamin A. You can get it in bell peppers and all kinds of other brightly colored fruits and vegetables. Anything that's pretty much orangey or yellowy, you should think of vitamin A. So cantaloupe and such. When you think of vitamin B, and it says complexes because you saw there's B1, 2, and so on and so forth, wherever there's one B vitamin, there's all the B vitamins. So a complex is just a group of things, right? So vitamin B complexes, they help you metabolize, as I said, carbohydrates, proteins, and fats. They help you use the energy-yielding nutrients. And you can see that they are in animal foods. You can see that they are also in plant foods, just a sampling, but it emphasizes whole grain as well, right? Vitamin C, think fruits and vegetables. Again, there are deficiency diseases. If you are truly deficient in vitamin C, you develop something called scurvy. Your skin gets all funkified, lots of bad things happen. That's how we learned that somebody was deficient in something. What is this weird stuff going on with this person's body? And we discovered that they hadn't had any access to fresh fruits and vegetables because they'd been traveling across the seas for months on a ship back in the day of Vikings and such, right? And we went, hey, oh my gosh, this is what happens when you eat nothing but potted meat for months. Let's give them fruits and vegetables. And oh, lo and behold, they got better. That's a really abbreviated version of a much more complex story. If you want to go online and read about limeys, Limeys, which was a name for sailors, you'll get a fascinating story about that. Vitamin D, again, you know it's going to help you absorb calcium. That's not all it does. Like I said, it has many other roles that make it very, very important. I don't want everybody eating a dozen eggs a day. I don't want people gorging on fats. So that's why I say sunlight. I will tell you that the richest food source of vitamin D, and again, you still got to get it from other sources, but the richest food source that most of us are likely willing to consume is salmon. So salmon's a fatty fish, and it's in the fat of the salmon because it's a fat-soluble vitamin. And you already heard me speak of vitamin K, and it helps your blood clot. So think about that. That baby comes into the world, has a sterile GI tract. It has no bacteria in there, so it can't make vitamin K. That would be a crisis. If that baby had an external or an internal injury that involved bleeding, that blood would not clot. That's why we give that baby vitamin K, so that its blood will be able to clot, so it won't bleed to death if there's any kind of a situation. So a vitamin deficiency is the condition that results from a long-term lack of a vitamin. It's not, oh, I didn't have any vitamin C the past couple days, which is virtually impossible unless you're just eating cardboard, but a long-term deficiency, weeks or months, right, depending. When not enough is coming in, it's a primary deficiency. When there's not enough absorption, it's a secondary deficiency. So again, nobody is just interested medically that you don't have enough of something. We're interested in why. Again, let's look at the problem and solve the problem. Just saying eat more of something is not a solution. So alcoholism, that's definitely going to deplete nutrients in the water. For one thing, alcohol is a diuretic, so it's flushing out water-soluble vitamins. Smoking increases your body's needs for many vitamins, making it harder to get what you need. Smoking has many, many downsides. Smoking, in fact, is the leading cause of strokes and heart attacks. I find it fascinating that always people think of smoking with lung cancer. They forget about lip cancer and throat cancer, and they don't even think about how it's damaging the blood vessels through the entire body and causing strokes and heart attacks. So here's just yet another concern. So we have dietary reference intakes. This is just a little sample of the fact that we have all these specific amounts that we know people need for adequate amount depending upon their age or stage of life. I don't expect you to follow micrograms a day. Again, focus on the big picture. When you have a vast variety of healthy foods in your diet, you'll be healthy. So if you are a food service professional trying to prepare enjoyable, healthy meals for people, variety is the first word. Color is the second word. Plants is the third word, right? It's all about the big picture, not sweating a bunch of little details. And we've done so much to destroy food in the past 100 years. And why have we done that? Well, we had good intentions. We were trying to find a way to get food to everybody. 100 years ago, you were stuck with whatever you could get around you. And maybe there wasn't enough of certain things because there was a drought or a pest infestation or whatever. Or maybe certain things didn't grow in that area and there wasn't much variety. So they wanted to get foods to everybody because there were gaps of people throughout this country starving and others not getting enough. So we began to try to look at ways to make food more sustainable and to get it to be more shelf stable so we could transport it and store it. Really good intentions. We began refining grains, taking parts out of them. We discovered if we take out the fat, it can't turn rancid. That means the grain will last longer, so we will have grain when we need it. And then we can make bread out of it and stick it on shelves and it won't mold as quickly. Well, that's all fine and dandy, but what we didn't know is that we were taking valuable fats and fibers and such out of it by refining it. So finally, the law said, my gosh, we're actually causing some vitamin deficiencies by feeding people foods that are missing vitamins. So we're going to say you got to put some stuff back in. Fortification became a law. They only picked certain things that people were most deficient in, and it pretty much solved the problem. But, we don't want to all be sitting around eating loaves and loaves of bread to get what we need anymore, because now we realize that that's not a great choice either. So our knowledge is constantly evolving, and it really comes back to the basics time and again. If you want the right balance of everything, and you want everything, variety, 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 everything in moderation, lots of plants. There's room for everything, but lots of plants. Who is most likely to be deficient? Somebody living in poverty. They're either not getting enough food or they're only getting the least healthful food regularly. Food fatism, people embracing kookadoodle diets. We don't eat these food groups at all. We banish this food altogether because they fail to realize what they're giving up that's good when they give up something they think is bad. People taking a lot of medications. What you don't understand probably is that nutrients and drugs are both chemicals, and chemicals interact. And sometimes certain drugs prevent your body from absorbing certain nutrients. Sometimes certain nutrients prevent your body from absorbing certain drugs, and then you don't get the effect you needed from the drug. Things are complicated. So the more drugs you're on, the more your health professionals need to know. The more nutrients you're on, the more your health professionals need to know, right? So you always want to tell your health professionals every medication you're taking and every supplement you might be taking, because the supplement might be causing more problems than good. And that's why food is best. Alcoholism, as I already mentioned, malabsorption diseases. We're going to look at intestinal disorders later, like Crohn's disease that you've probably heard of, or ulcerative colitis. And as we get older, we tend to have lesser appetites. We don't take in enough food. It's hard to get enough nutrition, and our bodies, as I mentioned, don't absorb things as well. That's in developed countries like ours. Now, when you think of a developing country, you should think of somebody in a place where you see a commercial for frail, emaciated, sickly children who are starving, where people don't have enough food and have a very, very harsh living environment. That's a developing country. In those cases, they just don't get enough of anything, right? But here, our bigger problem is too much of most things, or something that's wrong with us making things an issue. I'm going to let you read the rest of the screen. So these are the actual vitamin deficiency diseases. Again, just because you think you're not getting enough of something doesn't mean you have a deficiency disease. This is when you truly fall below the DRI for something, the dietary reference intake. Here's how much we know you need. You're below that. It would be obvious that something was wrong because you would have outward signs and symptoms. You might have super scaly skin, your hair is falling out, and so on, depending upon which one of these. It's beyond the scope of this course to go into these in too much detail. Here's an example, though, and we can look back here real quick. Actually, let's consider, it's not even on this one, is it? Let's consider vitamin D. So you know that you need sunlight to make vitamin D, and you need vitamin D to absorb calcium. So if somebody doesn't have enough vitamin D, or somebody doesn't have enough calcium, then they're going to have poor bone density, right? Because your bones are largely made of minerals. Phosphorus and calcium are the primary minerals making up your bones. If you look at that top matrix of bone that says normal, you can see there aren't big gaps. It's still woven like a lattice work, but there aren't big gaps there. If you look at the bottom, it's much more porous. It looks more like Swiss cheese. So the bone is going to be less dense. It's softer. Osteomalacia means soft bones. So in children, soft bones don't solidify correctly as they develop, and children develop these bowed legs that they can be cursed with for life. In children, poor bone density disease is called rickets. In adults, we develop osteomalacia, and it turns into osteoporosis. Now, what about the opposite? Too much. Let me clarify again. You are easily going to get what you need of most vitamins from food. And your body is an incredible piece of machinery that's all about homeostasis, keeping everything in balance. So it is pretty darn good at saying, thank you, I'll take what I need, I'll excrete the rest. Even fat-soluble vitamins. But once you start introducing concentrated amounts, which is what you get when you take supplements, your body can't regulate all that. So vitamin toxicity is not likely to come from food. It's the result of using supplements, which is why they should only be used under the guidance of a medical professional. Somebody should evaluate you, tell you do this, don't do this, And honestly, why would you want to take stuff that's a waste of your money if you don't need it? You could take that same money and spend it on more healthy food and get a whole bunch of valuable things at one time, right? More bang for your bite and more bang for your buck. So vitamin toxicity can be a really big deal depending upon the vitamin. So this is just to kind of give you a general summary. You can come back and look at this if you want me to give you the slides. So minerals, we're going to do very briefly, and that'll conclude things. I told you before, minerals are of the earth. When you think of the ground, you think of the earth. The earth's crust is made up of minerals, and everything that grows out of the earth therefore contains minerals, and we eat that, or another animal eats it, and we eat the animal, and that's how we get minerals. They are not carbon-based, and they are things that we need more or less of. So trace minerals, we're not even going to get into all the different minerals because trace minerals aren't things you have to think about too much. Most of us aren't going to have to worry about selenium intake and things like that. And in this class, we don't need to study all the different minerals. You just need to know that there are trace minerals and major minerals. So we care about the major ones like calcium. We care about potassium, we care about sodium, right? Those are the ones we mostly care about. Most of them are pretty darn easy to get, and they have a lot of really important jobs to do, as you can see right here. So we need to talk about a couple of them, because it ties into what you care about in terms of food production and health. Sodium is abbreviated Na, if you don't know that, and it exists in everything. It's a mineral, right? It's of the earth. Everything that comes out of the earth contains minerals, therefore everything that comes out of the earth, whether it's water bubbling up from the earth in a stream, a lake, or otherwise, or a plant, contains sodium. If an animal eats it, the animal consumes that sodium. We eat the animal, we get the sodium. All food contains sodium naturally in teeny tiny amounts. It has been a common preservative since the beginning of time. Man learned that salt was a compound of sodium and chloride. Man found salt ponds that would dry up and evaporate the water, and it would leave these crystals everywhere. And they figured out that if they took these chunks of crystals and they rubbed them on meat, that it would draw the water out. Think of making beef jerky, dried meats, right? You draw the water out. Well, one thing that bacteria needs to thrive is moisture. And if you draw the water out, then there's less moisture, which means the bacteria don't thrive, which means the meat won't go bad as quickly. So to preserve meat, you can dry it out. Things like salt curing meat, like hams that we hang and salt cure. So that's something people have been doing forever because they stumbled across these big crystals and figured out if you rubbed them on there, it would do that. Think about if you ever cook eggplant. If you have any skill in the kitchen, you know that if you cook eggplant, you slice the eggplant, you lay it in a colander, you sprinkle it with salt, you put paper towels, you lay more eggplant, you sprinkle it with salt, you put paper towels. The paper towels soak up all the fluid because the salt draws the fluid out of the eggplant, and then you pull the paper towels out and the eggplant is dry enough that when you cook it, it's not a big watery, mushy mess, right? So sodium is like a magnet for fluid. Sodium is a mineral. Chloride is a mineral. They can sometimes exist together in nature, like in a salt pond where the water has dried up and those two minerals formed a crystal compound, or sodium can be all by itself. So manufacturers discovered very quickly, if you put a ton of salt in everything, sodium chloride, right here, everything's gonna taste salty. Everybody doesn't want everything to taste salty. So they said, sometimes we'll just use just sodium because that will act as a preservative without the salty taste. So let me go backwards. Whoops. Sorry about that. Should have made that slide twice. When they just put sodium in the food, it's not always salt, but it's a preservative. And we use tons of sodium preservatives, as you know. So breads are always high in sodium because you need salt in the chemistry of baking, and then you need sodium preservatives to preserve the bread. Highly processed meats, salami, pastrami, lunch meats, ham, bacon, sausage, all of that, full of sodium because these are preservatives. Cheeses always have a lot of sodium because salt is essential in the cheese making process, and sometimes they add sodium preservatives. Snacky foods like crackers and chips have salt on them, and they usually have sodium preservatives in them. So many things in cans and boxes and bags have sodium preservatives, and this is why I taught you. If you look on the sodium line and it is 5% or less, it is low in sodium. That means it probably doesn't have a lot of sodium preservatives nor a lot of added salt. And the lower in sodium the ingredients are, the more room it leaves to add a little actual salt for flavor later, and it won't take somebody over the limit for their sodium intake. So why does it matter? Because, as you know, there are a lot of jobs of minerals, and one function of minerals is that they are electrolytes. You've all heard, oh, if somebody works out really hard, they should drink something like Gatorade. It's electrolytes. Well, that's for athletes, and unless you already established that you're an athlete, you're never going to need any Gatorade unless you are outside for hours sweating your butt off, right? Maybe then. But by and large, electrolytes are what help move fluid around in our body, so they're responsible for proper hydration. They keep intracellular fluid inside the cells, extracellular fluid outside the cells. Sodium attracts fluid such that it pulls it out of the cells and into those extracellular spaces. In other words, it draws it from the cells and into the surrounding areas and into the blood vessels. The more fluid that enters the blood vessel, the greater the volume of the blood, therefore the more pressure on the walls of the vessel. This is why high sodium intake for many people results in high blood pressure. Too much sodium intake, high blood pressure. So low sodium intake, lower blood pressure. Pretty easy, right? We categorize blood pressure by normal, elevated, and high. Now, normal doesn't mean everybody has to be there. It's just kind of like the maximum amount. It's like a TUL. It's like you want to be here or a little less. This is your worst case scenario. So a really good blood pressure would be less than 120/80. For example, my normal blood pressure is around 160/74, or 116 rather, over about 174. It's always right around there within a couple of points. That's really good blood pressure. The higher it goes, the more pressure there is in the vessels. The more pressure there is in the vessels, the more damage there is to the vessels. And we're going to talk more about that later. This is to help you connect the dots. If it's over a certain number, and you can see that here in the red, and it's there all the time, then you are told you have the form of cardiovascular disease called high blood pressure. It's one form of cardiovascular disease that causes other forms of cardiovascular disease. If you get to that hypertensive crisis point, that means you could have a stroke and die, amongst other things. So, how do you have low blood pressure? Lots of plant foods, because they're very low in sodium. Sticking with things that nature created. This is what you're trying to avoid. The leading causes of kidney failure, and this is an area of my expertise, I work in dialysis. The leading causes of kidney failure, kidney disease, starts out and progresses to kidney failure. The leading causes are high blood pressure and diabetes. If we can prevent high blood pressure and diabetes through a healthy lifestyle, we can prevent kidney disease and kidney failure. Anything that damages one vessel anywhere, guys, damages the others. If it's damaging the vessels in your heart, it's damaging the ones in your brain and in your eyes and in your kidneys and even in your penis if you have one. So, you can see here that the compound, two minerals stuck together called sodium chloride, is only 40% sodium. It's not even that much. So the thing you call salt on the table or in the kitchen is a compound of two minerals, the lesser of which is sodium. So think about it again logically. The less sodium in all of the ingredients, the more room there is to add a little bit of salt at the end for flavor. This is for cooking, for chefs, and this is for people looking out for their health. So you learned all about the nutrition facts panel. You learned there's a tolerable upper limit for sodium. To put it in perspective, the tolerable upper limit for people with no known health problems is about 2,300 milligrams a day. If somebody has diabetes or high blood pressure or some other form of cardiovascular disease, then we usually say don't exceed about 1,500 milligrams a day, whereas the average American intake, thanks to all the preservatives plus the addition of salt, is usually at least 3,000 to 5,000. You Google any restaurant that has a website with nutrition information and look up the sodium content for the typical meal, it's going to be 3,000 to 5,000 for one meal. Because all of the ingredients are full of sodium preservatives, and then a bunch of salt gets added as well in many cases. Use this knowledge to prepare better foods for your clientele in the food service industry. People like me want to go out to eat and enjoy ourselves too, and not kill ourselves in the process, right? So a lot of people want to partake of these opportunities for a fine dining experience, but not have to feel like they're sacrificing their health. You can see that a single teaspoon of actual salt is the maximum, the TUL for sodium, for people with no known health problems. I'd rather pick everything 5% or less sodium and know that that was a fraction of my 2,300 for the day and be able to use up to a half a teaspoon or 3/4 of a teaspoon or even a teaspoon of salt a day so that I can use it and actually taste it. It's not an exact science, it's all estimates, but it gives you perspective. I'm going to say one last thing about this. I meet people all the time in the health field who are my patients or clients who say, I don't eat a lot of sodium. I don't put salt on anything. And I say, well, tell me what you eat. And we talk about what they eat, and I write it all down. And I realize that they are taking in massive quantities of sodium. They're not using any salt, but all their ingredients. They make a sandwich. The bread's full of sodium. They put cheese on it. The cheese is full of sodium. They put lunch meat on it. The lunch meat's full of sodium. They put condiments and pickles on it. They're both full of sodium. They go through their day eating high sodium foods without any salt, and they think they're not consuming much sodium. People don't understand the difference between sodium and salt. Salt is partially comprised of the mineral sodium. The mineral sodium is the health concern. So what else can you do besides cut back on sodium? Well, if you want to get away with a little more, if you want to CYA, you can do the opposite. If sodium is what's pulling fluid out of the cells into the vessel, what can we get that pulls it out of the vessel and back into the cell? Potassium. Potassium counters sodium, so it draws it into the cell. So think about it. Potassium-rich foods are fruits and vegetables and dairy. Kefir is like liquid yogurt. If we're consuming low-fat kefir, low-fat milk, or low-fat yogurt, we're getting a lot of potassium. And the more colorful fruits and vegetables or nuts and seeds, plant foods that we are consuming, the more potassium we're consuming. So you can get away with even more sodium when you have more potassium. Again, I prefer choosing low sodium foods, high potassium foods, and being able to add even more salt as a result of that, because the salt is what tastes good. When you understand, you can work magic with food. All right, I know it was a long one, but we covered 3 topics. We had to do 3 separate sections for the others. We just covered 3 topics. Again, if you want the slides, I'm happy to give them to you. Just drop me a line in an email. If you have questions, ask me before you submit the assignment. I want you to feel knowledgeable and empowered. And very shortly, we're going to be putting all this together in terms of actual food. So I want you to feel like you're ready to do that. Thank you so much.